Everyone's buzzing about AI, but behind every breakthrough, every lightning-fast response, every large-scale model, there's an invisible superhero doing the real heavy lifting. It's Kubernetes. You see, in 2025, ChatGPT hit 800 million weekly active users. When OpenAI handles billions of requests per day, Kubernetes silently spin up thousands of GPU paths during peak demand and tear them down the moment traffic drops. No human babysitting. The same thing happens in gaming when millions of players simultaneously jump into Xbox cloud gaming. Kubernetes automatically scales services to ensure that no one experiences lag or downtime. And here's the part nobody talks about. Today's most innovative AI startups run their production workloads on Kubernetes. So in this video, let's talk about how Kubernetes actually works, why AI depends on it, and which AI startups are betting big on Kubernetes and why. Let's dive in. But hold on, what exactly is Kubernetes? The word Kubernetes comes from the ancient Greek for pilot or helmsman, meaning the person at the helm who steers the ship. And it is shortened to K8S because there are 8 letters between the K and the S. So in plain English, Kubernetes is an open source container orchestration platform. But the story gets better. It began when 3 Google engineers, Greg McNulty, John Bida, and Brandon Burns pitched a radical idea, an open-source system that could manage containers at a massive scale. The foundation of modern cloud-native computing was born. Under the hood, Kubernetes is built around 2 main layers: the control plane and worker nodes. The control plane is the brain of Kubernetes, the system that maintains the desired state of your entire cluster. Think of it as constantly asking, where are we right now, and where should we be? It's powered by 4 core components: the API server, etcd, the scheduler, and the controller manager. API server, think of this as Kubernetes front door. It exposes the entire Kubernetes API, handles every REST request, and processes everything from creating a pod to scaling its deployment. Then it comes to etcd. It is a distributed key value store that remembers API server data, basically everything about your cluster nodes, pods, configures, secrets, the whole state. If the API server is the front door, etcd is the memory. The Java scheduler is simple but critical. It assigns each pod to the right node, like choosing the best seat for every passenger on the plane. Last but not least, controller manager. Is reality still matching the desired state? If something crashes, it automatically restores it. Now, let's talk about their worker nodes, the machines that actually run your applications. Each worker node has 3 key components: Kubernetes, a local agent that stores and monitors containers, keeps them healthy, and makes sure everything on the node matches the desired state defined by the control plane. To proxy, it configures all network rules on the node. This is what makes Kubernetes services work, handling internal networking, load balancing, and forwarding TCP, UDP, or HTTP traffic using simple string routing or round-robin across backend. Container runtime. This is the engine that actually runs your containers, such as Docker Engine, Containerd, Creo, Uratus, Container Runtime, you name it. Together, those components turn a messy cluster of machines into one unified self-managing platform where applications deploy automatically, recover instantly, and scale seamlessly without human intervention. So, what does Kubernetes have to do with AI? When people imagine what's behind the AI, they picture massive data centers packed with powerful GPUs. That AI infrastructure is a combination of hardware and software stack built to train massive AI models. But here's the part most people miss. Brutal AI infrastructure helps you train powerful AI models, but running and managing these models at a global scale is a completely different challenge. This is where Kubernetes comes into play. By the way, if you're curious about how LLMs are actually trained, there's a full video already on the channel. Check it out if you're interested. Kubernetes automates the hardest part of AI workloads: GPU scheduling at large scale, workload orchestration, load balancing inferencing traffic, autoscaling fleet of containers, and keeping distributed systems alive 24/7. Remember when NVIDIA acquired OpenAI? That wasn't random. OpenAI built a GPU orchestration layer on top of Kubernetes, letting teams dynamically allocate GPUs, schedule jobs, share resources, and squeezing maximum performance out of their compute. Kubernetes also adds true multi-cloud portability. Teams can move workloads between different clouds, from AWS to Azure, GCP, or on-premises clusters, without rewriting code. Kubernetes is designed for high availability and reliability. Autoscaling keeps workloads healthy, running updates avoid downtime, and self-constellation constantly brings the system back to its desired state. But let's be honest, Kubernetes isn't magic. It's powerful, but yes, for many organizations, painfully complex. That's why you keep hearing stories of companies walking away from Kubernetes. Why? Because what engineers call sophisticated may keep experience complexity both in Kubernetes itself and across a huge ecosystem of tools you certainly expect it to utilize. Historically, Kubernetes excels at stateless workloads running at a massive scale, but stateful workloads such as databases, vector stores, or even Kafka streams are completely different beasts. Over the years, Kubernetes is getting better at handling them, but the learning curve is steep. Some teams hit scaling issues or operational pain and end up retreating back to the simplicity of VMs. And here's a real problem. Kubernetes can run anything, but only if you have people who know how to run Kubernetes. Engineers with deep real-world production Kubernetes experience, they are rare, and that scarcity drops salaries through the roof, turning Kubernetes from free open source platform into a very expensive operational commitment. Since 2023, that challenge has hit even harder. Wall Street is hyping AI, but at the same time, companies are slashing budgets, restructuring teams, and laying off tech talents left and right. Are those the days when organizations paid premium salaries just to keep Kubernetes experts in-house? Yeah, those days are gone. So before you jump into Kubernetes, you'd better ask, do we have the talent and the budget to run it the way it actually needs to be run? Despite the controversy, many companies still run their production data and AI systems on Kubernetes today. Like NVIDIA running Kubernetes and even built an entire cloud-native stack as a crucial abstraction layer, which we detailed in this video, Adobe, and more. Even some AI startups are betting big on Kubernetes. Start with OpenAI. Large portions of OpenAI's internal infrastructure, including inferencing pipelines, batch processing, run on massive Azure Kubernetes service, AKS clusters. Imagine 800 million weekly active users on ChatGPT. When traffic surges, Kubernetes autoscale fleets of GPU-backed nodes behind the scenes. Anthropic, the company behind Claude, their inferencing workloads runs on Google Kubernetes Engine GKE because they rely on containerization. Kubernetes orchestrated jobs for portability and high availability across regions. Beyond these giants, Kubernetes is powering AI startups in every domain. And if you're not using Kubernetes directly, you may be on one of these managed Kubernetes platforms. In healthcare, Babylon Health built its AI diagnostic engine entirely on Kubernetes, then used Kubeflow to automate its ML pipeline for ingestion to deployment. Alphasense migrated fully to Kubernetes, cutting deployments from hours to minutes and increasing release frequency by 30 times. Nora AI used the managed Kubernetes platform to avoid having a full DevOps team, boosting their productivity by 10 times. And Cast AI pushes Kubernetes to its limits, optimizing GPU clusters, eliminating idle nodes, and cutting LLMs cloud bill by up to 15%. In 2025, CNCF Cloud Native Computing Foundation just launched the Certified Kubernetes AI Conformance Program, which is a new standard for how AI should run Kubernetes clusters. Think of it as AI on Kubernetes, but consistent everywhere. It means developers can finally run AI workloads reliably across clouds or on-premises with zero vendor lock-in and predictable behavior every time. The global Kubernetes market hit $1.7 billion in 2023 and is projected to grow to $11.8 billion by 2032, a 24% CAGR compound growth. Safe to say, Kubernetes isn't going anywhere. It's growing with AI, and the ecosystem around it is exploding. Brandon Bird, co-founder of Kubernetes, wrote in my book, Certified Kubernetes Administrator Exangad, the expectations of business, customers, and users of today's applications have never been greater. Kubernetes and cloud native are the skills that will enable you to build applications that meet the standards necessary to compete in the world of modern application development. So, if you are a tech professional or entrepreneur, Scaling up on Kubernetes and cloud-native tools is more than just useful, it's competitive advantage. If you enjoy this breakdown, you may be interested in other videos in this Kubernetes in 30 Days playlist. I'm also adding a new series called Cloud Native and AI from zero to production to the same playlist in the coming weeks. Now you're watching this episode 1, so subscribe to our channel and I'll see there if you're interested. I'll see you in the next one.